Pleasant morning to one and all. I'm Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, I'm going to discuss about the activation functions in neural network. The activation function is a process of building a neural network. One of the choice we need to have is all about the hidden layer as well as the output layer of the network. And the basic elements that is all about the neural network is all about the input layer and the hidden layers. The input layer is a layer which accepts the input features, which provides the information from the outside world to the network, and no computation is required at this layer, and the node here just passed on the information featured to the hidden layers. And the hidden layer is all about the node of these layers are not exposed to the outer world. They are the part of the abstraction provided by any neural network. The hidden layer perform all sort of computations on the feature entered through the input layer and transfer the results to the output layer. And we have the last layer as an output layer. This layer brings up the information which is led by the network to the outer world. And the basic activation functions and why we use them is all about this activation function decides whether a neuron should be activated or not by calculating the weighted sum and further adding the bias to it. The main purpose of the activation function is to introduce a non-linearity into the output of the neurons. We know that the neural network has a neuron that works in correspondingness with the weight, bias, and their respective activation function. In neural network, we could activate the weight and the bias of the neurons or the bias of the error at the output. The process we know that this is as a back propagation. The activation functions makes back propagation possible since the gradient are applied along with the error to update the weight and biases. Sigmoid activation functions. Why we need to have a sigmoid activation function is all about a neuron, that is neural network without any activation function is essential, just a linear regression model. The activation function does the nonlinear transformations to the input, makes it capable to learn and perform some complex task. And the rectified linear unit is all about we have some mathematical formulas or the proof which will states for the rectified linear gradients which analyze effectiveness of the neural network. And we have the linear functions where the equations were given to which we call it as a leakly RLU and parametric RLU. No matter how many layers we have, if all the linears in nature, the final activation functions of the last layer is nothing but just a linear functions of the input of the first layer. Linear activation function is used at just one place, that is output layer. The basic issue which will arise is all about it differentiate the linear function to bring a non-linearity result which no more further dependent on the input, and the functions will constraints with an parametric groundbreaking behaviors of our algorithm. We have some hyperbolic target functions with an equations we can state with the tan functions, and the activation function that work almost always better than the sigmoid functions in tan functions, which we know as a tangent hyperbolic function. It actually mathematically shifted versions of the sigmoid function. Both are similar and can be derived from each other's. The tangent function, that is RLU function, is it stands as I stated about exponent linear functions, is where we have a vanishing gradient with an exponential linear unit, non-linear, very less computational, inexpensive than tan H, and sigmoid because it involves a simpler mathematical operation. At all time, only fewer neurons are activated, making a network phrase, making it efficient and easy for the computations. So hence with the activation functions with the basic rules of thumb, we can really do not know when what activation functions to use. Then simply we can use RLU as a general activation functions in hidden layer and is used for the most of these days. Optimizing your activation functions, which helps you to have the basic rules. If your output is for the binary classifications and the sigmoid functions, is very natural choice for the output layer. And if your output is multi-class classification, then the soft text is used for predict the probabilities of each classes. The basic challenges which we faced on this on this activation function is all about the activation function that works almost better, as I stated you about the sigmoid functions. Usually you used on the hidden layers of the neural network, as it lies between -1 and -1, and the exploring it merges on various neural network. The We can have a very simplest, as I stated you about the activation functions. It can be used on the model accuracy and convergence of this, crucially when we have your activation functions to show the performance statistics when implements your hidden layer in the neural network. So I hope you're clear with this activation functions. Thank you.